Okay, let's get the show on the road for the first real attempt at creating a video on this series. I will say in advance, I'll probably fumble through a couple of things as I'm working to work out how to do this developer as I go for the purpose of creating an entertaining, informative, and engaging video. If I fail on that, I'm trying, but feel free to drop any constructive feedback that you may have in the comments. In an effort to keep some sort of rails on this, I suppose, I've got a timer set up on my phone for 1 hour. I want to see what I can achieve in 1 hour of real world time. I don't expect the video to actually be an hour. I've also got a whiteboard with a couple of points sketched out, which we will cut over to right now. So the first thing we're going to try and achieve today is we're going to set up the SGDK development environment on my machine. We're then going to see if we can run Hello World ROM, which will indicate that we've got the dev environment set up successfully. A couple of challenges I identify. SGDK targets development on Windows, frowny face. I use Ubuntu for my daily drivers at home, but there is a thing that I've heard of in my very quick Googlings called MarsDev, which I think tries to make this a bit easier to work on Linux. Also, I prefer using CLion by JetBrains as my integrated development environment, or IDE, over VS Code, but a lot of folks in tutorials seem to like using VS Code. I may try to get this working in CLion at some point, or I might just take this as an opportunity to become more familiar with VS Code environment. A lot of the grads at my day job use it, and sometimes I just feel a little lost in the interface because I'm not very familiar with it. Also, shout out to Pigsy's Retro Game Dev Tutorials. His videos are a couple years old, but I've watched a whole bunch of those videos already coming into this. This sort of helped inspire me and get the inertia and feelings of hopelessness to dissipate a little. And for bonus measure, we've got pictures of my dog, Willow, because the dog is awesome. Okay, so first order of business is let's see about getting SGDK on my development machine. Okay, getting started. So it contains a development library itself with the source code, custom tools used to compile resources, uses GCC compiler for the M68K, which is the CPU of the Mega Drive, and libgcc to generate a ROM image. A couple of things here. So yes, SGDK, if I haven't mentioned it, is the Sega Genesis development kit. It's quite popular these days, and it uses the C programming language. Again, I'm not using this channel, initially at least, as a vector to teach people how to program in C. That's a thing that is probably best served elsewhere. This really is just recording me working out this thing I might be able to do. We've got some technical info references. I've looked at some of these in the past just out of curiosity. I will quickly shout out one thing I've looked at already, even though it's jumping ahead a bit. In terms of tools, I was wondering that, am I gonna have any hope on having Linux-friendly tools for sprites and graphics in particular? I can say that Aces Sprite, again, probably pronounced that incorrectly, that's actually available on Steam, and it will run natively on my Ubuntu environment on Steam. I bought it on a sale. Cost me like 20 bucks. I don't know. I think it's going to be well worth it. And already I've found there's plenty of good tutorials on how to use that. So when I get to making semi-meaningful graphics, I'll probably use that. And Deflamask is another one here that seems to have a lot of functionality and tutorials behind it. And I've bought a copy of that for, I think it was $3 US. It was very little and it looks quite promising. Another thing I am going to do, which is something I need to get more comfortable and proficient with as a developer, is to leverage conversational GPT API, AIs. Yes, admittedly, when these things first showed up, my developer brain was kind of, there was fear, okay? Because unlike some things that were gonna shake up how code is done in the past, no code, no code, this stuff's actually kind of scary. It could take my job if I sit on my hands, so gonna have a look at that. What that means is I'm not gonna be backwards in asking ChatGPT for some guidance. So let's do that. I want to begin developing with SGDK, developing Mega Drive games with SGDK. I use Ubuntu 24.04. So guidance on making SGDK work on Linux is going to be a must. Okay, let's see what ChatGPT 5.2 has to say. Just found Mars Dev Linux installation toolchain setup. I think there used to be GenDev, but I picked up somewhere that in a comment that it hadn't been updated for a while, and Mars Dev seems to be the hotness. Pretty sure Mars was the original code name for the Mega Drive internal to Sega back in the 80s. Okay, let's have a look at what we've got here. Option A, recommended, Mars Dev toolchain and SGDK. Native Linux workflow. Mars Dev is cross-platform Mega Drive toolchain that builds and installs the M68K tools you need. It's commonly used for Linux SGDK setups. So we need to use Ubuntu's package manager apt to install. I mean, I've already got Git, should have much of this. Not entirely sure about the OpenJDK, Open Java Development Kit. I guess SGDK uses Java for a lot of its tooling, which is a good choice. Coming over here now to my terminal. Let's paste that in. Oh, hang on. Right. Yeah, it does appear to be installing OpenJDK, and it's done. Yep, no errors. Build and install Mars Dev. Okay, so we need to clone this Git repo, then update the submodules and make the M68K toolchain. Okay, I put for source code management, I tend to put all my cloned repos into one common directory. So we will clone Mars Dev into here. According to ChatGPT, we need to initialize submodules. Okay, that seems to have completed successfully. Okay, make-J, which speeds up parallel building, which might be useful here. Let me just quickly check exactly how many cores my system believes it has, which you can do by finding how many times the megahertz line shows up in /proc/CPU info. There's a little tip for you. And because I'm lazy, I'll count the line. 16. So in theory, we could get away with 16 cores. So let's do that. Okay, looks like it's W getting a bunch of stuff. Oh, I wonder, is this creating Docker containers or something? That's wild speculation there. While this is compiling, we can look at step number 3 in advance, where it says load the Mars Dev environment to put the tools on our system's path, our shell's path. Okay, we need to source. Right, so a lot of goodies will be in this opt toolchain mars.shell file. Exact variable names vary by project template, but the concept is the same. Your project's makefile needs to know where SGDK lives, and the toolchain must be on the path. Okay, speaking of toolchain, if we come back over here to our terminal, that all appears to have worked. So if we go source our bash RC file, no such file or directory. Where did it put that then? Toolchain installed. Here we go. To home. Oh. I don't think I wanted to do that. But I think I would have preferred to have it installed outside of the Git repo. Yeah, because now Git believes that there's new content to track, which is the toolchain. Okay, what we will try is see if we can just lift and shift the where the default invocation of the make has installed it into the Git repo to the path that ChatGPT is referencing. Let's just jump into the directory where it said it installed things. And see if we can find the mars.shell script. We can't. Okay. We've got option B here. Use ready-made Docker toolchain. Fastest to it builds. That sounds like what I want. You can avoid cross-compiler build pain. That does sound like some pain I want to avoid. There are SGDK-focused images, including Stefan D's published container image. Okay, tell me these two things and I'll tell you the exact commands templates. Let's go with Docker. And number 2, I will want to use real hardware eventually. Either way, once you answer, I'll give you a copy-paste project skeleton that prints text, reads control input, and moves a sprite. The classic SGDK on-ramp. Okay, well, we ultimately want a hello world, so let's answer that question. Now, on the topic of hello world, folks may have heard or seen that for programming tutorials, one of the first things that is almost always done is hello world. It's very easy to make the mistake of thinking that hello world is so unexciting and so worthless. What's the point? Let me do something meaningful. As software development environments get more and more complicated, trust me, hello world is very valuable because sometimes half the battle is just setting up the bloody toolchain. So hello world can prove that you've got the correct libraries installed, you've got the correct compilers and other tools installed, you've got all the paths correctly set up so that everything knows where to find the other bits that it needs, and any configuration is functional. So hello world is not to be sneezed at. That's a takeaway for budding programmers out there. Disagree? Feel free to drop a comment. Docker plus eventually real hardware is a great combo in Ubuntu because it keeps your build environment deterministic. Oh, that's a big one for development. And hardware testing is mostly about flashcart workflow plus a few real console gotchas. Okay. According to this, even SGDK 2.11 release notes highlight that SGDK has been improving its Docker setup. For Docker workflows, we can use the official container image. We might just grab the pre-built image from the project maintainers. I could build it myself if I wanted to be if I needed to customize it or control or be paranoid about what's in there. This snippet here is going to run the image. Because I don't have it on my machine yet, it should download it from GHCR. I think that was referenced here is GitHub Container Registry. Container Registry is just a place where folks can stash their pre-built Docker images for other people to use, usually. You can always create your own, but you don't tell anyone about those. So what this will do is, yes, it will download the image. It will run make inside that Docker container. There's plenty of good tutorials out there on how Docker works and getting started with using Docker, so I'm not going to explain that at any length here. Again, I'm ultimately here to try and create a Mega Drive game, not teach you everything along the way. Let me learn it first, then I might come back and teach people. Let's just back up to my home project for this channel, home folder for this channel. We will run, I'm not sure if I actually have Docker on this machine. I do not. So now this should still, okay. The Podman setup has linked the Docker command to Podman. Good job. Writing manifest image destination, make. No rule to make, target, make. Okay, and the reason that's an issue is because this here in our Docker command is saying we need to create a volume where on our host machine, my dev computer, it will take the current directory, and inside the container, it will put that, make it appear as /source directory. That's what that line here is saying. And -w, I think, changes the working directory to /source, and then we run this command once we're there, and then make itself is the one that's making this, raising this complaint down here, because I can't find a make file. What I might do then is just go back into my source code root directory where I stash all my repositories. I haven't created a GitHub for this yet. I'm not sure if I'm going to make it free as I go along, how publicly available, but for right now, I just need to get this thing to build. So let's assume that ultimately there will be a repository for this thing. I should at least use Git locally, because that's what smart developers do. I was thinking a name for this in terms of, I gave it 5 seconds, I thought Mega Tower. Very creative, I know, so let's do that. Mega Tower. Git initialize, okay. So now we go git status, and there's nothing in there. Okay, but we've got a Git repository locally, so we can work with that. If this is going to be the source for our the root directory for our project itself, what we might do is I want to take that that Docker run snippet thingo that ChatGPT gave us before. We might turn that into a shell script. Build it Docker style. I need our shebang line for our shell script. Put that in there. Change the mode of the file. Add executable bit. Okay, so now it hasn't done all of this image downloading stuff because I've got a copy of the image locally. Let's go podman image list. There we go. So it's created, it's pulled down and made a local copy of that Docker image to run containers from. Again, look up how Docker works. So what we don't have is any example code now. Okay, I think what we could do is clone SGDK itself from GitHub, which is the thing we still haven't done yet, and maybe find an example in there. So we need to go back over to GitHub and get the SGDK repo. So we're going to code, clone, copy that, and we'll clone it into here. No such file or directory. That's because I didn't add the git clone command before it. Okay. Sample, let's have a look at sample. Oh, there's a hello world one here. So let's have a look at main.c and draw text, hello world. Okay, so what we have here is this would be our one-off initialization code, and this is basically the game loop. And the Mega Drive essentially runs at 50 or 60 ticks per second, depending on the analog video standard that's used. It only really has one source of interrupts, as I understand it, which is, maybe another one for H-blank, but vertical blanking, which is, so when your CRT would finish scanning a full screen and get to the bottom, there's a period where it's got to go back up to the top left. That's the vertical blanking period. And with graphics, what you want to do is make changes in that period, so copying stuff into memory for the display. You want to make those changes in that period where nothing's actually being no changes are being reflected on the screen, because we're in that blanking period as it goes back to the start. So that will avoid artifacts like tearing and glitching sort of stuff in your graphics. That's not just a Mega Drive thing, that's a pretty basic computer graphics approach. Oh, we've just ticked over half hour real world time. Okay, so we've got code that should do a thing. What I want to do is let's just copy all of these C files. Okay, and then we'll change into that directory. There's no make file though. We must need to actually, let's find where the make file was for Hello World. Okay, we've got a DOS batch file called build samples. Let's see what that does. Okay, so these all look like they're referencing identical make files that have what I'd consider a non-standard name, but it can be It doesn't have to be called makefile with a capital M. Okay, so what we need to do is find that file. Oh, okay. So if we copy this into where we have our demo dummy project. Okay, we can do the Docker style build. So this file, this folder's contents, the source and the makefile should go into our Docker containers file system for the make command inside there to pick up and build. Right. What I might do, because I kind of want to debug what's inside this container. Wait. I think this make command that's being run inside the container here isn't specifying the -f flag and makefile.gen. So if we'll make a symbolic link, makefile.gen to be called makefile. It's not going to autocomplete something that doesn't exist yet. If we try our docker build command again, that should work. Or not. What am I getting wrong here? In an effort to debug why this container's not just working, I've created a copy of our build script with a couple minor changes. Those changes are basically here. We're overriding the command that's run when the container launches to be just a basic shell. I tried using bash, it's not built into the container. What that allows us to do is rather than try and run that make command in a one-off container, we will do this, and this drops us into our working directory /source. So now we can actually have a look at, this is the file system inside the container view. If we go make, cannot find SGDK environment, but that also shows that make has found our makefile. If we have a look at the root, remember this is the inside our container. If we have a look at the root of that container's file system, we have SGDK. If we have a look inside that, does it look like... Okay, so let's try, before we go out of the container, let's try setting the missing environment variable that this line is complaining about. SGDK equals /SGDK. I'm not sure if that's correct, but this will help us find out. Okay. Okay, well that didn't work quite as expected, so let's just see if we can Google, or we'll drop this into ChatGPT. I followed path A, yet when I make gives me the following error. Okay, so error message, make, no rule to make, target, make, stop. Means make is already being run. Okay, so make, the make command itself is probably the entry point command which is run by default in the Docker container when it's run. Right, and that's what ChatGPT seems to be saying here. What you should do instead is just run the container no make command. The container's entry point is already make. Let's prove that. That's very easy. We just need to drop this last line. Save that. Oh, look at that. Can't create directory source. Permission denied. Well, let's ask ChatGPT what it has to say about this. I think I know what the problem's going to be, but definitely not explaining this right now. God, I'm a horrible teacher. Okay, your suggested change to the way the container is run did work, but now the error is permission denied. Yeah, a user group ID mismatch between the container user and your host folder permissions. Knew that. I mean, I did. I just explained it really poorly, so just take my word for it. God, I'm doing a horrible job of this. You mounted your project into the container. Inside the container, the build tries to create source inside that mounted directory, but the user inside the container doesn't have permission to write to your host directory as mounted. So fix 1, run the container as your Linux user. Yeah, we want to explicitly set the user and group IDs to be used. Okay, let's do that in our build it script. We could probably put that there. But it just still keeps coming back to failing. And if I look at who owns the files inside my container, they list as root, but then who am I shows as my username Owen. If I touch test.txt, okay, failed, right. I see there's a user permissions issue now. So I'm gonna ask ChatGPT, even when running with my user ID with the -u command you've suggested. This seems to be the problem with file system permissions inside the container. Let me just quickly fix the actual spelling mistakes. So I'm back and forth with ChatGPT now to try and work out exactly why it's getting permission denied. And it looks like it might be a user ID mapping issue, and we've got some code that says, hey, just run as root inside the container and see if how that affects things. It's a user ID mapping issue. Rootless Docker, which is what Podman praises itself to be. Okay, so maybe my choice of Podman instead of Docker is the problem here. So the quick and simple fix it's suggesting is run inside the container as root, and I might need to change the ownership of things on the host. That's fine, I can do that. Just in case we want to come back to that, we'll just comment out that -u example. Okay. Now we're getting real build fails. Multiple definition of ROM header. Okay, it's been a while since I've done C, but that might be because of this ROM header is different to what's in the containers SGDK, maybe? We'll just rename this and let's try again. Definition of ROM header. Let's remove the output just in case it's not cleaning up a symbol, and try rebuilding again. Oh, did that work? Ooh, I do have clown MD emu on this machine, so let's see if rom.bin works. Oh my goodness, it does! Oh, finally, I got Hello World to work. See, this is why Hello World is not a joke, okay? Respect Hello World, because it can signify a damn lot. It looks like the issues I were having compared to what ChatGPT was... I really should have told ChatGPT earlier on that I was using Podman for my Docker engine instead of Docker proper. Because Podman praises itself on being rootless containers, which has permissions benefits and safety benefits. I'm just used to using Podman as a Docker alternative at work. So a lot of the problems came down to how the rootless containers handle user and group ID mappings. So I was never running as my true self inside the container, and all this stuff owned as root was failing, and we were getting permission denied. I should have told GPT earlier, and it probably could have given me more correct answers sooner. hey, lessons learned. Once I fixed that up and had to, I think we did have to update the GDK environment variable to get that to work. And also to get around the user and group ID mapping stuff, we just added this line here to say, hey, look, run as root inside the container. And that basically gives us super user permissions inside the container to do whatever we want. And we ran a successful hello world. That is what I wanted to achieve. I'm just looking up at my whiteboard. Yeah, we set up SGDK dev kinda, but rather than a native on my machine build, we did use Docker containers. I haven't chosen an IDE of choice yet. It might not matter that much just yet. Ultimately, we got our hello world, and that's what I wanted from this very first video. Oh, apologize for the tedium, but hey, that's a good example of like sometimes software development sucks in all of those ways that you saw, ignoring the big chunks of time that I possibly cut out. I mean, full disclosure, as I'm speaking these words, we are about to tick over 1 hour, 23 minutes and 40 seconds of real world recording time. Keep that in mind when you look at what the actual timestamp is in the video. Big chunks were cut out. That's the truth of software dev. Sometimes just getting set up to be able to develop software can be the most painful part. Okay, folks, that's the first video done. I'm going to cut it here and yeah, see you in the next one, whenever that is.